because math life. All right, here we go. Note 3, limits numerically and analytically. I noticed that yesterday there was like 2 or 3 limits that I should not have put in there. And I know someone asked, they're like, child, there's an x in here, x times f of x or whatever. I should not have asked that. I should. So next year's notes will be better. So my apologies that I put that in there. You're going to see that this is like, I should have asked that question on this. The first thing we're gonna have a whole bunch of functions. It's like, let's just get started because I'm just gonna go blah blah blah. So these right here, these rules are the same rules from yesterday. I just typed them out a little different. So I just put in there like, look, it's a notes 2, some difference, constant multiple. It's the same rules, and these are the only ones that are new to you. And all that means is direct substitution to try it out. And then this is a variation of the power rule. It's the same rule. You already know it. So you pretty much already know it from notes 2. And of course, remember, this is what makes continuity. Limit as this approaches a of f of x equals L. Oh, no, actually, no, that's not continuity. If I had this equals f of L or f of a, then it's continuous. But if I just have this stuff, all that stuff to the left here, that's just your definition of what a limit is. The limit doesn't have to be continuous, right? It could aim towards like a hole or something. All right, relax. It's going to be simple, I promise. So look at Theorem 2. I got this from your textbook, so that's why it says Theorem 2, because they're keeping count of how many theorems they've given you guys. You can just scratch that out. If you were to read this textbook and you see, am I recording? Yeah, I am. And you see that box, does that make sense to you? Are you like, yeah, okay, that makes sense? No? Okay. I'm going to tell you what that box means. All this means is try direct substitution first. That's all that means. As long as the denominator is not 0, try direct substitution first. As long as denom, I'm just going to put denom for short, is not 0, try substitution first. What's up?
Do you have the only one right first name? Ruby?
Yeah, just right there.
Oh, that has stats.
Oh. I guess just not count. I mean, just good.
Do you want it? Okay.
There's Ms. Jones, guys. Sorry, Ms. Jones. Just wanted to say, like, tell them hello for you. Or you're welcome to stay if you want. We're just barely starting limits. We're doing direct substitution. That's the first thing.
Yeah. Always want to share direct substitution.
Yeah. So here we go. You guys ready, guys? So all you're gonna do, you're gonna look at a limit, and we've already been doing a whole bunch. Remember the properties with graphs and all that. So now look, I have no graph, right? So look at example 1. I have a limit as this approaches 3 of x squared 2 minus x. And what does it say to try? It's a direct substitution. See if it works. So can I do direct substitution on this? Yeah. 3 squared, 2 minus 3. And whatever that answer is your limit. 3 squared is 9. 2 minus 3 is negative 1. Negative 9. Done. That's it. Was that simple? Look at the next one. Can you do direct substitution on that one? Yes, as long as you don't get a 0 in the denominator. That's what it says. That's what this says. As long as you don't get a 0 in the denominator, try direct substitution. So don't worry, I see you, miss. So we're going to go 2 squared. Notice that I don't put the word limit in front anymore because I'm actually solving it. There's just numbers now. 2 squared plus 2 times 2 plus 4 all over 2 plus 2. And I guess technically you could leave it like that, but don't. 2 squared is 4, so 4 plus 4 plus 4 divided by 4. Well, there's 3 4s, so that must be 3. Or you can do 4, 8, 12 divided by 4, whatever. Cool or not cool? All right, what's up, Abdul Kareem?
Oh, you already answered.
Yeah. How do we feel? All right, we're going to need calculators. So does someone want to grab, there's already some calculators in your tables, but if you don't have a calculator, grab a calculator, guys, and then reset it. Do you know how to reset the calculators? Yeah, everyone, I want everyone to try it with me, guys. You can grab the new ones, it doesn't matter. Radians, always radians. Do you guys know how to reset the calculators? All right. As you can see, I have a lot of junk in my calculator right now. Here's how you reset them, all of them, even the old one. You push the second button. You push the plus button, it should say memory. And you push 7, 1, 2. And it should say something cleared or blah, blah, blah. And all of them should be the same thing. Second plus 7, 1, 2. Did it work? Perfect. Did it work? Okay. Here we go. So let's go back to the notes. So let's see. All right, cool. I think those are straightforward. This is me talking. You don't have to read it. So basically, I want this limit. So I want limit as x approaches 0 of this function. Now this right here tells me to try direct substitution as long as I don't get a 0 in the denominator. So I'm looking at it and I'm like, okay, if I were to try direct substitution, I want you guys to notice. Let's look at the square root. 0 plus 1 is 1. What's the square root of 1? 1. And what's 1 minus 1? So I get a 0 in the denominator. So now, just like this box told me, since I get a 0 in the denominator, can I try direct substitution? No. We have to try something else. Well, Chavez, what can we do? You could graph it. You know how all this time we've been graphing? We could graph it and see what happens as I approach 0. Or we can do something like this, that we can use a table and see what happens as we get closer and closer to 0. Look at these numbers. Negative 0.2, negative 0.1, negative 0.01, negative 0.001. Is it getting closer and closer to 0? Yeah. So let's see if we can figure this out. Take your calculator out, and I'm going to show it right here. Click on the y equals button. It's the one on the left-hand corner. And I'm going to use the fraction feature. So I'm going to push alpha y equals enter. But I just actually learned something new last night. Not last night because it wasn't night, during class. Jirella taught me something. Jirella taught me that I can get this fraction by just pushing, see, I don't even have it, alpha and then link, or out, and look, I get a fraction. I didn't know that because mine doesn't have a little fraction, but her calculator did. She has the Python calculator. Anyways, I just learned that. Okay, on the top, I'm going to type in the equation that I had, and I already forgot it. What did I have on the top? Was it x? Okay, I put an x. And in the bottom, I'm going to go to the bottom. I'm going to put second square root, and with it, x minus 1 or 1 minus x, or I already man, short-term memory real bad. X plus 1. X plus 1, and then scroll out of there, minus 1. All right, cool. I'm going to do one more thing because I don't want fractions. It's probably going to give me fractions as an answer. Click on mode. And mine way down here. Where are you? Okay, right there, fraction type. You see where it says, no, answer, where it says answer, sorry. You see, does yours say something that says answers and says auto and then DEC? Okay, go to decimal. That's what DEC stands for. Because I want a decimal. All right, here we go. Push the second button and push the table. Oh, I don't want that. Okay. Everyone should probably see something like that. I want to type numbers in to give me values, right? So I'm going to go again and push the second button and put table set, which is a window. So you should have something like that. And I'll wait. Okay. Table start. Yeah, I'll wait. I clicked the second button and I put the window button, which gets you the table set. Got it? Cool. So I want to. It doesn't matter where you start because I'm gonna make it independent. So where it says independent, put ask, like that, and where it says depend, it doesn't matter. Leave it as auto. So now ask is highlighted, and now check it out. When I go to my table, second table, it should be blank. Is it blank? All right. I'm gonna get closer and closer. I'm gonna do this, Chavez. I'm so lost. I haven't done anything, guys. I'm gonna do this right here. I'm gonna get closer and closer to 0 from the left. So I'm going to start it out by putting negative 0.2. So I'm going to go negative 0.2, enter. Put that number down on their table, 1.8944. 1.8944. I'll do it again. Don't worry. Now I want negative 0.1. So negative 0.1, enter. 1.9487. 1.9487. 487. Negative 0.01. Negative 0.01. Enter. 1.995. Okay, are you guys getting errors? Are you putting negative or minus? The negative is right next to the answer. Negative 0.001. Look at that. 9995. Yeah, from the left. Let me go check your calculator. Are you trying it? Perfect. Oh, look, you're good. X over. What's up? Abdul Kareem just asked if this were a function, because it is, f of x equals x over square root of x plus 1 minus 1, and they were to ask f of 0, would it be undefined? Yeah, it would, because you're not defined at 0. All right, so far, here's what I got. Does it look like as I approach 0 from the left, that I'm approaching a number? What value of f of x am I approaching? So I'm going to write limit as x approaches 0 from the left of x over square root of x plus 1 minus 1. Make sure that the minus 1's outside the square root. It looks like it's 2. So let's see if it's the same if I approach from the right. So I'm going to go back to my calculator. I'm just going to push the delete button. Delete, 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 delete. And here we go. I'm going to push 0.2, and I'm going to push enter. I'm going to push 0.1 and put those values down on your table. Enter. I'm going to push 0.01. Oh, wait, yeah. Enter. Is that as far as I go, or do I do 0.001? Yeah. 0.001. Enter. And there it is. Put those values down on your calculator, guys. 2.0954. Or you guys tell me the values. 2.0954. What's the other one? 0488. And then the other one, 2.05. And then finally the last one, 2.00. Do I have another 0? And then what do I have after that? Another 5? Another 5. Does that one look like it's approaching anything? No, look, check it out. 2.09, 2.04, 2.00, and then 2.000. I'm approaching what? 2. So limit as x approaches 0 from the right of that function is also equal to 2. How do we feel? Do I approach the same value from the left and right? So what can I say about this limit? It equals 2. Was that cool or what? That's not the only way you could do it. You could also look at a graph. If I were to look at a graph, don't do this, guys, because, don't do this. If I were to look at a graph, it looks like at 0 it's 2. Remember, it's undefined. I actually have a hole. But my calculator, one, has a lot of limitations. It's not an HD screen. First, that pixel is taken up by the y-axis, so you can't tell. But on Desmos, maybe you can. But yeah, because it doesn't look like I have a hole there. But I have a hole. If I were to tell the calculator to give me at 0, watch, second table. If I were to push 0, some of you probably already did. Do you think it's going to say 2, or do you think it's going to say error? It's going to say error. You're undefined. Does that make sense, guys? Good. So now you know of another way to do it. You can find limits by getting closer and closer to the value that you want. Was that cool or what? Yeah. What's up, Abdul Kareem? Oh, I thought you had a question. All right, here we go. We're doing the same thing with this one, guys. Sine x over x. This is one of my favorites. So I'm going to go to y equals. I'm going to clear it. I'm going to push alpha y equals enter for a fraction, or you can use the alpha link. I'll put sine x over x. I'm going to do the same thing again. Delete, delete, delete. Well, I guess I could have left it there. What am I approaching? Negative 2? Okay, I'm approaching from the left. Negative 0.2. I get that number. Negative 0.1. Negative 0.01. Negative 0.001. Okay, we got to be very, very careful. It says 1, but it's not 1, guys. Chavez, but it says 1. Look, hover over it. It's actually that. Oh, even better. Mine is not being that accurate. It's actually 0.9933. Okay, let me go ahead and put them in there. 0.9933, 0.9933, 0.99. I might have another 9. 9983, thank you. What's the next one? 0.999. 9998. Yeah, if it's rounded. And then the last one, 0.9999. Probably 8. No, another 9. 0.9. I'm going to leave it like that. Does it look like it's approaching something? Yeah, look, 0.9933, 0.9983, 0.99. It looks like the 9s just keep going larger and larger. Limit as x approaches 0 from the left of sine x over x looks like it's 1. I'm going to do the same thing again, but from the right. You probably already know what's going to happen, but verify it anyways. So I'm going to scroll to the left. Delete, 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 delete. 0.2, enter. 0.1, enter. 0.01, enter. 0.001, enter. Should be symmetric, so it should really be the same values. It's an even function. You should get the same values again, guys. 0.9933, 0.9983, 0.9998, 0.9999. Limit as x approaches 0 from the right of sine x over x is equal to 1. How do we feel? So we can conclude that this limit is 1. It's one of the special ones. Huh? Why the special? Because we use this one. You'll see. Before the end of the day, we're going to be using it. It's one of the special ones. Cool or not cool? Actually, you're going to be using this one the whole year from now until, for you engineers, forever. Well, at least until you graduate engineering school. All right. If we were to look at a graphing calculator, if I were to push graph, and if I were to zoom in, look, check it out. It definitely looks like it is 1. The limit as x approaches 0. Relax. I am not defined. There's a pixel. There's a pixel right there missing. It's a hole. But you can't tell. It looks like it's continuous. But it's a hole. If I were to push 0 on my graph here, on my table, it's going to tell me undefined. Watch. 0. We'll replace that. It's going to tell me error. Do you guys see that, guys? Okay. Perfect. Why? Because you can't divide by 0. So it's like, you know what I mean? All right. These are part of the special limits. Sine x over x equals 1. 1 minus cosine over x equals 0. And that one is equal to e. This one comes out often, but don't worry about that one so much at the moment. 1 and 2 come out all the time. That's the properties you're going to be using. And there's derivations of them. The reciprocal of 1 is 1. That's not the best that's not the best hack. But what I'm trying to say is I can switch these. So it says insert variation. So I can say limit as x approaches 0 of x over sine x. And this is also going to be 1. Does that make sense to you guys? All right, the argument has to be the same. Travis, what do you mean? So what I'm trying to say is this. It could also look like this. Limit, I still have to have an x value, a variable, as x approaches 0, and I can have sine happy face x over happy face x. That equals 1. John, I don't understand your happy faces. Okay. What I'm trying to say is if I tell you what's the limit as x approaches 0 of sine 3x, what's inside the parentheses is called an argument. If that's a 3x, then the bottom must be a 3x for this to equal 1. Does that make sense? Yes. You got to keep the... Yeah, you can't divide by 0, but it's part of the property. If I were to type this into my calculator, sine 3x over 3x, and I get closer and closer to 0, I would get 1 again, just like I did with my table. I'm going to get the exact same number. I'm going to get all the same numbers that I just did right now. I got to have... If you get closer to 0, you're going to get 1, yes. The argument has to be... If whatever the argument is, if I have 3x, then the bottom has to be 3x. If I have 3x over x, then this is not a limit of 1. That's a limit of 3. Yeah, you don't have the experience yet. I need to have, whatever the argument is, the bottom needs to be the same. You know what I mean? What's up? Yes. All right, check it out, Abdul Kareem. Let me just really quick. I already have a y equals in here, right? So let me change the top one to a 3x. Because you're probably like, I don't know how you did it so fast or whatever. 3x. I'm just making it worse and worse. 3 second insert x. All right, look at this second table and look at that number 0.1, 0.01, 0.001. It says 3, but it's not really 3, it's 2.999. See? The graph now looks like it's a transformation. Look how it looks. Remember, I'm still undefined at 0. I'm undefined at 0 because you can't divide by 0. 5. You know what I'm trying to say? Like this is the graph how it looks, sine 3x over x. There's a hole right here at 0, 3. So what's the limit as x approaches 0? 3. Because that 3x created that right there.
Yeah, but the reason I was confused is because if you plug in, if x is approaching 0, then what is it? Oh, okay.
The argument
So for 0,
this, to TBH, if you want to think about it, like sine 3x is a bigger number than like as I get closer to 0, the bottom is smaller than the top. You know what I mean? So that's what's creating that like a stretch-like thing. Someone had a question over here. I saw someone's hand up. Okay. All right. If I were to put a 3 here, guys, sorry. If I were to put a 3x there, notice that my numbers would be back to 1. 0.9851. Okay, that might be a little different, but I'm still going to be approaching 1. Does that make sense? Yeah, so I said that wrong, that it would be the same, but I'd still be approaching 1. That'd be the same. How do we feel? All right. This one here, it can be written, it doesn't have to be like that. It could also be written like this. Limit as x approaches 0 of cosine x minus 1 over x. That's still 0 like that. It's like you can pull a negative out, but it's still like over, you know what I mean? Like if it's 0, it's 0, 0 is 0. It's not positive or negative, so. Yay or nay, guys? Yeah, that's it. Yeah, nothing crazy. That's it. This one doesn't work with the reciprocal. How do we feel? All right, we're about to use a property. Let's see if we can use a property that we just learned. And I know you're probably saying like, man, Chad, this is getting really hard. Relax. It's going to be easy once we do this over and over. Determine the limit as x approaches 0 for 10x over x. First, I see if I can do direct substitution. Can I do direct substitution? Why not? I get a 0 in the bottom. Perfect. So then I'm like, okay, and here's your pre-cal. It's not even heavy pre-cal. It's just a baby pre-cal. The only thing I know right now is limit as x approaches 0 of sine x over x is zero. Is not zero. Is 1, and the other way around as well is 1. That's all I know. That's a side note. So what I'm going to try to do is I'm going to try to use sine x. So I'm going to turn that tan. So I'm going to put this in the side here. So tan x, hopefully everyone knows, tan x is what over what? Sine over cosine x. Cool? So here we go. I'm going to write the word limit as x approaches 0. And instead of writing tan x, I'm going to write sine x over cosine x. There's my tan x. And all that is over x. Are we still okay? All right. I can either do the keep, change, flip, or I can move that x right next to that cosine. However it works in your brain. Let's do another side note. A, B is a fraction, and I'm dividing by c. So that c is like c over 1. Keep, change, flip. A over b times 1 over c. Notice that I have a over bc. So all I could have done is just put that right next to that b there. So I can rewrite this, and I have not simplified the limit, so I got to keep writing the word limit. Limit as x approaches 0 of sine x over x cosine x. Am I still okay? Okay. This is just like chemistry. I'm just going to expand. So I'm just going to expand. I'm going to write the word limit as x approaches 0. I'm going to put a giant parenthesis because I'm expanding what I have on the inside. I want to make sure that my expression is still the same. So I'm going to write it like this. I'm going to write sine x over x times 1 over cosine x, close parenthesis. And don't worry, I'm going to slow down so I can explain. If I multiply this expression that I have in parentheses, if I multiply that expression in parentheses, do I still have sine x over x cosine x? Yeah, we're in business. Now this is a property that I can use. And usually I don't break it down like this, guys, because usually I just go right into it, but I'll do it one time. And if you guys get confused, let me know. This is just one of my properties that I can use. Blah, 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 blah. It's just being multiplied. See? F of x times g of x. I can write it as limit of f of x times limit of g of x. Do you guys see that? So I can write this down as limit as x approaches 0 of sine x over x times limit as x approaches 0. And I'm going to erase the side note, guys, so I can make room for this. Of 1 over cosine x. I don't always do this. Usually I just go right from here, but I want to make sure that you guys can see it. Are we still okay? All right, we just found out what this limit is right here in blue. What is that? That's just 1. Can I do direct substitution for the 1 over cosine x? Yes. What is cosine of 0? Oh, it's what? It's not 0. It's 1. Guys, I was your pre-calc teacher. I failed. Cosine of 0 is 1. That's why you can do direct substitution. You don't get a 0 in the denominator. In case you're trying to visualize a unit circle, here's my unit circle. That coordinate is 1, 0. Cosine of 0 is 1. That's why we can do direct substitution. So I have 1 times 1 over 1. So 1 times 1 over 1 is just what? 1. So there it is. That's my new limit. If you want to add this one as a special limit, I guess you can if you want to. So if you want to, come over here and then write limit as x approaches 0 of tan x over x is 1. And so is the reciprocal. Limit as x approaches 0 of x over tan x is 1. Well, I guess you could also do the happy face. Limit as x approaches 0 of tan happy face with an x over happy face with an x is always going to be 1. Oh, you don't like the happy faces? You're a happy face hater? I believe in science. I want triangles. All right, let me give you triangles, Ms. Abdul Kareem. Limit as x approaches 0 of tan of triangle x over triangle x is 1. There. Yeah. Yeah. In science, it's, yeah. Oh, and math is almost also means delta. Cool or not cool? All right. I think we're ready. I think we're ready. You got it? Yeah. Here we go. Yes, what's up, Gonzalez? Cosine 0 is equal to 1. Yeah. Yep. Good job, miss. All right. We could graph this. We can make a table. But now, look, I just want to show you, we can do algebraic manipulation. Hey, no yawning. That's the next one's a demerit. Okay, sorry. That was a joke. All right. Here we go. You guys ready? Can I do direct substitution right now? No, why not? But I noticed that in the top, that is the difference of, so I can do limit, because I haven't evaluated it, as x approaches 1, and then I just separate it. X plus 1, x minus 1, all over x minus 1. What's going to cancel? X minus 1's cancel out. Now can I do direct sub? What is 1 plus 1? There it is. That's my limit. You would have a hole at x equals 1, yeah. Yes. I would actually rewrite it, guys. Technically, I would, okay, this is correct. No one's going to take away points. But I would just do that. I would cancel it, and then I would rewrite it as limit as x approaches 1 of x squared minus 1 over x minus 1 is 2. But no one's going to take away points. You're fine. How do we feel? No, it's correct. Correct math is correct math. All right, let's see if we can get to some harder ones. Well, I mean, they're not really that tough, guys. They're pretty much the same. Letter A doesn't even have any derivation. It's the same thing, but I just did the reciprocal. So you can probably guess that it's going to be a half, and it's correct. All right, so again, letter A, the bottom is the difference of squares. You cannot do direct substitution because you get 0 in the denominator. So here we go. Limit as x approaches 1 of x minus 1 in the numerator, and in the bottom I have x plus 1, x minus 1. The x minus 1's cancel out. I can now do direct substitution. Remember that I have a fraction, so the 1's in the top. 1 plus 1 is 2, so it's a half. How do we feel? Okay. Next one, letter B. I look at it. Can I do direct substitution? Again, no. But I can factor something out. What can I factor out in the numerator and denominator? Someone said it. Say it loud and proud. It's okay if we're wrong. I heard someone say it over here somewhere. X squared. So here we go. Factor out an x squared. I'm going to have 3x plus 20 over, here's my x squared factor out on the denominator. I'm going to have a 5x squared minus 10. That's a minus there. Let me just fix it a little bit. All right, what's going to cancel out? The x squares cancel out. So now I'm going to rewrite it. I haven't evaluated it. Limit as x approaches 0 of 3x plus 20 over 5x squared minus 10 is nothing more than, I plug in a 0, 20 over negative 10, which reduces to, not everyone at the same time, negative 2. Notice that I kept writing the word limit until I finally plugged in the 0. So you have to keep writing that word limit. Well, like as long as you have an expression. If you still have an expression in terms of x, keep writing it. You know what I mean? What's up?
Question. So what did you do with the 3x and the 5x?
I plugged in the 0.
Oh.
3 times 0. I probably should be showing those steps. I'm sorry, miss. Yes, Gonzalez, what's up? Oh, I have an x plus 1 on the bottom. So I need to keep that, when I add 1 plus 1, I need to keep that 2 in the bottom. I have a 1 here. It's a fraction. Well, because I have a fraction. There's no hole at 1. There's a hole. Oh, yeah, there is a hole at 1. There's a hole at 1. But, because it's a fraction, so I gotta keep it a fraction. It's a 1 in the numerator, you know what I mean? Like, okay, I gotta keep the 2 in the bottom, like, period. I can't make the answer 2 because the y value is a half when x is 1. No, you're good, you're good, you're good. How do we feel, guys? We feel okay? Can we take some more or no? All right, here we go. I have this one here. Here's where your algebra is going to come in. I know we did some of these questions last year in pre-cal, in the very beginning, around this time. 1 over 2 plus x minus 1/2 over x. Can I do direct substitution? No, because I can't divide by 0. So I need to have, so here we go. Limit as x approaches 0, and I'm going to leave some space. 1 over 2 plus x minus 1/2 all over some x. And I made some space because I'm going to be getting a common denominator. So if you have colored pencils, it is a good place, or colored ink, it is a good place to switch it up. I need a common denominator in the numerator. So I'm going to multiply the top by 2 plus x over 2 plus x. I'm going to multiply the 1 over 2 plus x by 2 over 2. Does everyone know what I'm doing? I'm getting a common denominator in the numerator. When I do that, limit, I haven't evaluated it yet, so you got to keep writing the word limit. Either that or write the algebra on the side somewhere and then come back to it. So I have 2 over 2 parentheses 2 plus x, do not distribute it, minus 2 plus x over 2 parentheses 2 plus x. Don't worry, I'll come back to you. All over x. What's up, miss?
So I figured it out. I was like, why aren't you writing 4 plus x? But
Yeah, I didn't distribute it. What's up, Marcello? The 1/2 by x plus 1. Oh, I did multiply the 1/2 by 2 plus x, but I kept the denominator in the bottom. 2 times 2 plus x. 1 times 2 plus x is 1, and then 2 times 2 plus... Nothing cancels right now. Don't. Did I lose you, Paracello, or? Oh, what was the question? Tell me again.
I was just wondering if you could just multiply the half by x plus 1, and then you want to multiply the other fraction by 2.
I think it would still work, but in my brain, I think this works easier for everyone. But yeah, I think that would still work too. You know what I mean? All right, here we go. Are we okay so far? So now I have a common denominator in the numerator, if that makes sense. I'm going to put it all in one nice, pretty limit. Limit as x approaches 0, 2 minus 2. I'm going to just, don't forget to distribute that negative. 2 minus x over x, I guess I could say 2x. 2x parenthesis 2 plus x. Have I confused anyone? I did the keep change flip. I brought the x up. When I brought it up, I just paired it with the 2. Cool? Okay. Here is the right way to do it. I see some students always canceling the x's, and it irks me because you can't just cancel it out immediately. You got to zero some stuff out first, and then you can cancel out a product with a quotient because they're like inverse operations. 2 minus 2, does that zero out? This zeroes out. Now that you zeroed that out, you only have one term in the top. So I have an x divided by 2 times x plus 2 plus x. What can I cancel out? Now you can cancel out an x and an x. Are we still okay? Now I can evaluate this limit because now look, can I make x approach 0? Say yes. All right, and I'll slow down. Yes, you can because you do not get a 0 in the denominator. Look what you get. In the numerator, check it out, Gonzalez. What do I have in the numerator? A negative 1? A negative 1 divided by, if I make x approach 0, 2 plus 0 is 2. And what's 2 times 2? 4. And I'll put here for good notes, 0. So you get 2 times 2 plus 0, which equals 4. What's up, Gonzalez? Initially. Correct. I'm doing algebraic manipulation. How do we feel? All right. I don't know if you have enough experience, Miss Abdul Kareem, But do you think you can look at letter D here and tell me what the output's going to be? No, just looking at it. Yeah. You already saw a pattern real quick. All right. Oh, sorry. Are they okay? You guys can ask me if you want. Pollos, are you guys okay, Pollos? Ask. It's all good. I did this. Where did I add the x? Oh, this x right here? That x is this x. I did the keep change flip. I'll do it right here on the side. I did this. 2 minus parenthesis 2 plus x. I'm doing this part. All over 2 parenthesis 2 plus x. And all this is over x like that, right? I put that up there. Keep change flip. You know what I mean? All right, so check it out. I love these. And now, don't be a robot. It's very easy to become a robot. Just use your chemistry skills when you were balancing formulas. If you have 5 oxygens on the right, you got to have your 5 oxygens. They just don't disappear. Now, you extract them, and you can repel them, and you can move them around, but they don't disappear. Have you guys had chem? Okay. So check it out. Here we go. Look at this. I have, that's everything. I have that little, okay. Limit as x approaches 0. I'm going to use a parenthesis. I can't do anything with that 2x there, guys. That has to stay there with the sign. So I'm going to write sine 2x over, I guess I don't need a giant parenthesis, but I'm going to put something here, times something, and then close it. I put some space because I'm going to add something to it. Remember what we said. The only thing we know, and I'm going to slow down. I'm going to go as slow as I can. The only thing we know is that limit as x approaches, I'm looking at this one right here. Limit as x approaches 0 for sine happy face x over happy face x equals 1. Are we okay with that? So that's the only thing we know. At the moment, I need to force that sine 2x over that x to equal 1. How do I force it to be a 1? I make the bottom a 2x. I have an x, so what do I got to force to put in the bottom? A 2. Now, this isn't magic. I can't just magically add numbers where I want. So if I put a 2 in the bottom, I need to balance it by putting a 2 in the top. So here's my top and the bottom, or on the side, 2 over 1. Did you guys see what I did? Well, to show a fraction. To show, yeah. So that 2 there is for balance.
So theoretically, it's multiplying by 2 over 2.
Yeah. Multiplying by 1, 2 over 2, which doesn't change anything. Does that make sense?
Yes.
Now check it out, guys. Now I can solve this limit. And I don't want to use the limit rule again, because I don't want to write all that. This here that I'm circling, sine 2x over 2x, that is just what? 1. And look, what is 2 over 1? 2. So what is 1 times 2? 2. So that answer is 2. Yes. I put it in there. I'm the one that forced it. Remember that I need to have sine happy face over happy face. Well, I balanced it. I put in a 2. I put a 2 on the outside. So really, it's like I multiplied the whole thing by 2 over 2. If I multiply by 2 over 2, 2 over 2 is just 1.
Can I just write 2 over 2?
Yeah, you can. If you just want to go like sine 2x. But it's because if I write 2 over 2, you're not seeing, I guess you can do another step and then go sine 2x and then put the 2 in the front over 2x. And then this that I'm circling, if I put the word limit in the front, that I'm circling is 1. 2 times 1. I need to have this, and I need to have the argument and this match. They must match for this limit to be a 1. Just for the stuff that I circled. So that's why I forced that blue, that 2 in there. I put the 2 in the bottom. If I put a 2 in the bottom, I better put a 2 in the top. Just make one up. I'm going to make one up. And I'm going to erase it. Don't write this down. Just listen. Sine. I'm going to make a good one up. 5x over 3 limit as x approaches 0. Right now, this limit is not 1, right? I got to put an x. Can't have that. Right now, this limit is not 1. I need a force. The only rule I know is that sine of 5x over 5x, that equals 1. So I need to force a 5 in the bottom somehow. So I'm going to rewrite it, and don't write this down, just listen. Limit as x approaches 0, sine 5x. I can't do anything about that 5x in the top of the argument. That stays with the sign all the time. That 3 and that x, I can separate it however I want. I'm going to put an x, tot, fraction, 3. Put a 1 in the top, boom, boom. Is that the same thing? I haven't changed anything, right? Now check it out. I must have a 5 at the bottom. I must. Because that's the only way that this limit sine 5x over blah x is going to be 1. I must put a 5. If I put a 5 in the bottom, what do I got to do to the top? Put a 5. I must. So it's like I multiplied the whole thing by 5 over 5. See, here's a 5 in the top. There's a 5 in the bottom. 5 over 5. 1. 5 over 5 is over, like, if I put a 5 in the bottom, you got to put a 5 in the top. Now that I did that, this here that I'm circling in blue, that limit is 1. And look, 1 times 5 is 5 and over 3. So 1 times 5 over 3. So this answer is 5/3. Okay, let me show you a hack. And I don't like it because it's very robotic. If you see this limit, you can just say, oh, that's a 5, that's a 3, this is going to equal 5/3. But don't do that because that's very wrong and it's very robotic. But that's a pattern.
Is it like you can still cancel out the 5s so it stays the same?
No, the 5s don't cancel out. It's you cannot like sine 5x over 5x. This is not a product. You can't do that. It's sine of 5x.
I'm saying like when you look at
The green 5s? Oh, yeah. That green 5 and that green 5
by balance?
by balance. They cancel out. It's a 1.
Okay, then where'd you get the 5 from? The side?
That 3 came from this 3. Huh?
No, where'd you get the little 5 from?
Oh, 1 times 5/3.
So that's like no one.
Yay, we're winning, miss. Look at you being boss. I think you should celebrate tonight. I think, you know what? I'm feeling generous. I will give you, and I don't care if it's in French or Mandarin. If your parents only speak Chinese, that's fine. If your parents email me, Spanish, English, Japanese, whatever, telling me that you genuinely sat down with them and had a conversation about limits and showed them all this awesome math, and they email me that you really did. Now, don't cheat the system and be like, Mom, Dad, email Mr. Chavez and tell him that I spoke to you. Like, sit down with them. Like, literally sit down. When you have dinner tonight, like, parents, I want to, or guardians, I want to show you. Look at all this cool. Like, sit down, have at least a 5-minute conversation about math, about all the stuff that you're learning. And if they email me that you had that conversation, I'll add 5 points to your test. That's a lot of points. But it must be real. Don't make it fake.
How do you do that?
You're going to sit with her?
So I'll text you.
Okay, yes.
Okay.
Or, let's make it more formal. Let's do the email and be like, okay, Mom, you're emailing Chavez. What are you going to tell him? And I want it to be your mom's words. And if your mom, if it's Spanish, give it to me in Spanish. Yeah, no, guys, I'm Hispanic. I can. Okay, here we go. So you're gonna talk to your adults, right?
Yeah.
You're gonna talk to your adults. All right, miss, 5 extra points, 5 easy points. Okay, guys, talk to your parents, talk to your guardians. The sooner the better. Go have some math life memories. We're only on this earth for so long. Like, invest some time with your guardians, with your adults. You're only a year or two away from leaving them probably forever. So let's take this moment to have those little conversations while we still have time. We're still here among the living. We still got this. So you can still invest time with your familia, with your people that are important to you. Because not everyone has parents. Some have guardians and whatnot. Okay, Oh, sorry, miss. I was about to start. Keep going. What's up? What's the question? For which one? D? Okay. Oh, yeah. It's sine of 2x and it times 2, but you do not, that argument, you can't touch it. It's part of sine. So you leave it alone. Yeah, that's a common mistake too. All right, look at letter E. Can I do direct substitution? No, but when you had algebra 2, you learned the difference of cubes. I think in pre-calc we did it also, but not at the extreme as algebra 2. Do you remember the difference of cubes? It's weird. Man, it's not weird.
Oh, is it? Would it be x minus 5, 25, x plus 2?
There you go. You got it. Write this down. This is the difference of cubes, guys. It is the formula. A minus b, a squared plus ab plus b squared. That is called the what? Difference of cubes. There's the difference of cubes. If you were to multiply these out, you will get a cubed minus b cubed. Are we cool? All right, so here we go. Now that we know that that's the difference of cubes, because 5 to the third power is 125, right? I'm going to expand it. Limit as x approaches 5. Giant parenthesis, because I'm going to have several terms here with a minus in the middle. I'm going to write x minus 5, close, open, x squared plus, let's see, it says ab, so I'm going to write 5x plus, and it says b squared. My b is 5. So I'm going to write 25, or you can write 5 squared if you want. All this is over x minus 5. Are we still okay? That's the same expression. What's going to cancel out? X minus 5. Now that I have those out, can I do direct substitution? Yes. So I'm going to go 5 squared plus 5 times 5 plus 25. It looks like it is 75. No, not always, but it just looks like it is because we've done this twice already, and it's 444 from the last one. Cool or not cool? What's up, Gonzalez? Yeah, I just said, see how I have x cubed here? So that was by x cubed minus, and it was 125. 125 is 5 cubed. So that's how I figured out that b was 5. Cool? All right. All right, guys, one more. Oh, I think we have 2 more. Do we have enough energy? Yeah. Letter F. Don't worry, letter F is not hard. At the moment, you cannot do direct substitution because you get a 0 in the denominator. Do you guys see that? But notice, what can you factor out in the denominator? Not a 2x, but a what? An x. So I have sine x over x parenthesis 2x minus 1. I'm going to expand it. Chavez, why are you expanding it? Because I see a sine x over x. So here we go. I'm going to change the colors so not to confuse it with all this stuff in red here. So I'm going to write limit as x approaches 0, giant parenthesis, and I'm going to write it as sine x over x times 1 over 2x minus 1. I didn't need to balance anything. It was already balanced for me. All I did was factor and expand. Are we okay? What is sine x over x as x approaches 0? 1. So I have 1 times. Can I do direct substitution for this part? Yes. 2 times 0 is 0. But luckily I have a minus 1. So that is going to be 1 over negative 1. Do you guys see that? So this limit is negative 1. What's up?
For the sin x over x equal 1, does it have to be approaching 0?
It must be approaching 0. X must be approaching 0. What's up? I plugged in a 0 into x 2 times 0 minus 1, and that gave me negative 1. If it was x approaching 5, I can just do direct substitution. It gives me a number. You know what I mean? How do you feel, guys? All right, here we go. Our last one. And don't worry, it's not going to take up the whole page. Maybe like half of it. And don't worry, we're going to be quick. We're going to be fast. Here comes the pre-cal. There's the last problem. Do you guys remember the Valentine's formula? Well, before I even get started, can I do direct substitution? No. What was the question of the claim? Okay. So we can do direct substitution, and you're like, man, Chav, I don't know anything about this. So the only rules you know right now is limit as x approaches 0 of sine happy face x over happy face x over happy face x. Oh man, my happy faces suck this time. We know that it's 1. And the hack, if you want to do the other one, which we're probably going to use this one, is tan happy face x over happy face x equals 1. Really, you can get the tan one from the sine one. But I can already see we're going to use tan on that. If you can't see that, it's okay. Don't worry. We're going to show you how to do it. Negative. If you do not see right away that 1 minus secant squared is equal to negative tan squared, that's okay. Do you remember the Valentine's formula from that you learned in pre-cal last year? Tell me my Valentine's formula. That's not the official name, but side note. Cool. Does everyone know that? All right. The only way I can get this to have a secant is if I divide everything by cosine, or cosine squared, because it's a secant squared. So I'm going to divide everything by cosine squared. This is on the side, guys. This is all side notes. Cosine squared over cosine squared, that's a 1. Sine squared over cosine squared, that's a tan squared. And 1 over cosine squared, that's a secant squared. Am I okay? I look at this expression and I see 1 minus secant squared, and I'm like, yeah, I can get this to be a 1 minus secant squared. I'm going to move the tan squared to the right. I'm going to move the secant squared to the left. And now I have this. 1 minus secant squared theta is equal to a negative tan squared theta. No, leave it like that, because we're going to use the tan x. So you'll see right now. How do we feel? All right, so here we go. And I got to keep the argument, whatever that argument is. The argument for the secant is the 4x, so I got to keep that. So I'm going to rewrite. So I'm going to put the word rewrite. Rewrite limit. Limit as x approaches 0 of a negative tan squared of 4x over 6x squared. Are we okay? The only hack we know is this one right now with the tan. With the tan, limit tan happy face x over happy face x equals 1. So I'm going to expand it. So here we go. I'm going to scroll down, and I'm going to write the word limit as x approaches 0. I'm going to put a giant parenthesis. And I'm going to write negative tan 4x. I know it's squared, but like I said, we're expanding it, right? Times tan 4x. And I'm going to go slow so you guys can see how rookies would do it. Is that tan squared at the moment? Yes. And then how many of the 6x's do I have? I have 2 of them. 6x times 6x. So I'm going to write 6x, 6x. Is that the same thing as what I have in the top? Okay. I am in business. How do we feel? All right. Then you're like, wow, I'm so close. I need to have the arguments the same for these 10x's to be the same. So that must mean I must move those 6's. You can't do anything about them. You got to keep them, right? So here we go. I'm going to rewrite it. Limit as x approaches 0, giant parenthesis, negative tan 4x. I'm keeping the x, but I'm moving the 6. Tan 4x. I'm keeping the x, but I'm moving the 6. And then here's where I'm moving them. I'm going to put 6 times 6. Or you can put 36. What do you guys prefer? You want to see the 6 times 6 or do you want to see the 36? Leave it like that? Okay, leave it like that. It's a fraction at the moment, 1 over that. Is that still the same? Okay, so here it is. I'm going to change my colors. If you have colored pencils or a different color ink, now's a good time. Whatever has a different color is stuff I added. Cool? What do I need in bottom of the first tan 4x for that to be a 1? What's going to be a negative 1 because of the negative? But a 4. Just a 4 because it doesn't have a negative on the inside. A 4. Now, if I put a 4 on the bottom, I got to put a 4 on the top. How do you feel, Paola? Perfect. All right, Paola, tell me. What does this tan 4x over blank x need for this to force this limit to be a 1? A 4. Now, if I put a 4 on the bottom, what do I got to do to the top? Add another 4. We're in business. I'm going to go back to my red. So check it out. Well, it just pops up to me. All right, here we go. You guys ready? So now this right here that I'm circling in green, and I know there's a negative in the front. That's okay. Tan 4x over 4x, according to my little theorem here, tan happy face x over happy face x, all that equals what? Yeah, 1 with the negative in the front. Yeah, it's going to be negative 1. So negative 1 times this again right here that I'm circling. Is that another 1? Times 1 times, and then I'm just going to leave it as 4 times 4 over 6 times 6. All right, what's 4 times 4? Well, I guess I could reduce it. No, let's leave it. 16 because I already started. Negative in the front because there's a negative in the very front. What's 6 times 6? 36. This reduces, I believe, 4 goes into, yeah, so negative 4 over, is it 9? And there it is. That's my limit. That's as hard as it gets. Yes. How do we feel? So right now we just need more practice. So let me give you, we're probably not going to be able to finish it today, so we'll probably take it for homework, and you have delta, but don't worry.